Our discussion about z-scores, the number of standard deviations from a mean, and outliers lends very well into this thing called the empirical rule, which looks at what percent of data values are going to fall within a certain number of standard deviations from the mean. Let's look visually at this thing called the empirical rule. The empirical rule says if I look at a number line where the mean of the population is right in the middle of that number line, we would expect to see lots of values in the population that are close to that mean, and very few values that are far away from that mean. This means that to the left of the mean, far to the left, there's very few values. But as I get closer to the mean, you'll start to see more and more values up until a maximum that occurs right at the mean. And then as you get bigger than the mean, you're going to start to see fewer and fewer values as it levels off to fewer and fewer values way off to the right of the mean. So the mean actually is right in the middle. It's going to split this distribution in half. Half of the values should be below the mean, and half of the values should be above the mean. But what's really interesting then is if we start counting standard deviations away from the mean. If I take the mean plus 1 standard deviation, or the mean minus 1 standard deviation, and we look at that range of values, it turns out that between those two values, we would expect to see 68% of all the values in the data set within 1 standard deviation of the mean. If we split this in half on either side, there's 34% of the values on the left and 34% of the values on the right that are 1 standard deviation above or 1 standard deviation below the mean. And we can extend this logic actually to the next unit, where we have the mean plus 2 standard deviations, or the mean minus 2 standard deviations, and get this range between 2 standard deviations from the mean. This was our standard for an outlier. It turns out that we would expect 95% of data values to be within 2 standard deviations of the mean. Anything outside of that we would consider an outlier. Well, if I take that 95% and cut it in half, we end up with 47.5% on either side. But we already have 34% in the blue, so this little green sliver turns out to be 13.5% on the left and 13.5% on the right. But we could go even further than that. We could come out here to mu minus 3 standard deviations, or mu plus 3 standard deviations. And if we're 3 standard deviations from the mean, it turns out that we can get 99.7% of all data values within 3 standard deviations of the mean. If we were to do the same process and cut that in half so that we can see what's on each side, subtract the 34% in blue, subtract the 13% in green, what that leaves is only 2.35% on each side. And then if we wanted to get really extreme to the values that are more than 3 standard deviations from the mean, in those extreme tails, we would call these extreme outliers. We could take the 100% under the curve minus the 99.7%. There's only 0.3% outside of these curves. And if we divide that in half on each side, there is 0.15% in each of these little tails. Now, what's nice about the empirical rule, then, is this gives us a way to figure out how many values are between certain points, certain number of standard deviations. For example, if I wanted to be between 0 standard deviations and 2 standard deviations above the mean, I could add those sections together. 34 plus 13.5% tells us that 47.5% of my values should be between the mean and 2 standard deviations above the mean. We could count to the left even. Let's say we want to go between the mean and 3 standard deviations. Well, then we're looking at the 2.35% in gray, plus the 13.5% in green, plus the 34% in blue. Adding those together, we end up with 49.85% of values are going to be between 3 standard deviations below the mean and the actual mean. So the empirical rule allows us to really gauge what percent of values are falling within certain ranges, and it becomes very useful to help us to decide where values are falling in relationship to the mean.